Support Technician, Level 3, KU1, Lecture 1. Part 1 Principles of Software Engineering, by Patrick Eustace, Ph.D. Acknowledgement. I would like to put it out and acknowledge with profound gratitude to my software engineering lecturers at the University of Greenwich and University of East London for helping to shape my knowledge of this subject, and from whom much of the texts, examples, and my foundation of the subject are derived. Lesson intent. To introduce software engineering principles that justify the need for systematic approaches to IT problem solving and systems development. Learning outcomes. By the end of this session, you will be able to describe the software crisis, define software engineering, define IT solutions, describe the methods, tools and procedures adopted in the software development process, review unique problems in software development, review quality systems and importance of good specification and design, review issues of maintenance, estimation and customer dissatisfaction in software development. Introduction. Software engineering is the study of the creation and development of computer programs that will meet user specifications and implied need. The term, software crisis, was coined and first came into press from the 1968 NATO conference. The term meant that software was expensive, of insufficient quality, hard to schedule and impossible to manage. The following are also true. It is widely believed that maintenance devours the running cost of hardware and software products, with software at about 16 to 25% of the license cost per year. USA and UK showed an ideal budget for software total cost at much higher, at almost 75 to 90%. 2014 to 2019 statements. Many questions were asked at the NATO conference that need answers. The conference felt that the world was in crisis due to the very many problems and issues highlighted. Below are just some of the questions that came out from that conference. Why does it take so long to get programs finished? Why are software costs so high? Why can't all errors be eliminated before giving the software to customers? Why do we have difficulty measuring progress of software development? Definition. To comprehend the principles of software engineering, it's essential to begin by defining and comprehending the term engineering. According to the Engineering Council, an engineer is someone who acquires and utilizes scientific, technical, and other relevant knowledge and skills to build, operate, and maintain efficient systems that are of practical and economic value. The Oxford English Dictionary describes engineering as the branch of science and technology concerned with designing, constructing, using engines, machines, and structures. Definition of software engineering. Software engineering is a discipline that involves the application of engineering principles and systematic approaches to the development, design, testing, maintenance, and documentation of software. It is a process-driven methodology that aims to create high-quality software products that meet customer requirements while adhering to the constraints of cost, time, and resources. The goal of software engineering is to ensure that software is reliable, efficient, maintainable, and scalable, and can be developed and delivered in a predictable and repeatable manner. Fritz Bauer, 1969, defined software engineering as the establishment and use of sound engineering principles in order to obtain economically software that is reliable and works efficiently on real machines. Definition of IT solution. An IT solution provided by support technicians is the totality of software program tools and/or services applied to provide possible solution to a business problem. Who is a support technician? The Institute for Apprenticeships and Technical Education described an IT solutions support technician as a modern IT personnel with a multidisciplinary skill set, who undertakes duties within a team across the complete IT solution, and works on the team's core activities in a modern, DevOps, style across the stages of solution lifecycle. IT solutions support technician develop, implement and maintain complete IT solutions, including hardware infrastructure, such as servers and networks, and software infrastructure, such as operating systems, middleware and applications. Classifications, roles and responsibilities. The field of software engineering is real, diverse and complex. Software engineers function in teams with different nomenclatures for different types of roles, e.g. DevOps engineer, test engineer, front-end engineer, back-end engineer, IT solution. High-integrity software. Software failures can lead to minor inconveniences or major consequences like financial losses and loss of life. In industries like healthcare, aviation, and nuclear power, software failures can have catastrophic consequences. Safety-critical, nuclear-critical, mission-critical, and life-critical software require extremely high levels of reliability, safety, and security. Examples: medical cardiac machines, renal dialysis machines, airplane fly-by-wire avionics, and spacecraft. These systems aim for zero defects because any fault or failure can lead to significant losses or even loss of life. Unique problems of software. Software is a non-tangible component of computer systems that exists as pure thought stuff, and can survive beyond the life of the engineering for which it was written. Software development, testing, and maintenance require a high level of skill and expertise due to its complexity. Unlike hardware, software deterioration can occur due to maintenance as it is a dynamic system that evolves over time. Software projects often see modifications, updates, and corrections released to address bugs, features, and improve performance. Software projects can be challenging to manage and often experience delays, cost overruns, and project failure. The Standish Group's Chaos Report reveals that approximately 15% of software projects fail to deliver any useful outcome. 62% of companies have experienced software projects that were over budget, behind schedule in the last 5 years. Proper software engineering processes are crucial, ensuring projects are timely, within budget, meet quality standards. Cancelled software projects due to massive cost overruns, schedule delays have been estimated to cost approximately $178 billion, the Standish Group's report. In 2018, poor quality software cost U.S. industries about $2.8 trillion, i.e. about 10% of U.S. GDP in 2017. Herb Krasner's CISQ reports 2018. Loss due to software failure cost a cumulative estimate of $1.9 trillion. Problems with legacy system cost 75% of total IT spend for care and maintenance at roughly $635 billion in expenses. 60% of work time was spent on finding and fixing defects alone during development at $500 billion, Capers-Jones. Technical debts from delayed work, shortcut pressures, bad work, latent weaknesses, vulnerabilities, and errors in software cost roughly $1.1 million to $1.6 million. Cast cost: Herb's 10-digit defect syndrome. Source: https://blog.overops.com, 13 May 2020. See you in Part 2. Goodbye.